Good morning, all of you, dear students. In this session, we are going to discuss two most important theorems in 1B in straight lines, particularly those are foot of the perpendicular theorem and image theorem. In these two, one will appear in our IPE exam frequently. Many times, either in 4 marks or 7 marks it will occur, it will appear, or the application of this theorem is in 2 marks. So, first we have to go to this, state and prove that foot of the perpendicular theorem. That is, what is foot of the perpendicular theorem? If that is statement, if q h comma k is the foot of the perpendicular with respect to the on the line ax plus by plus c is equal to 0, then foot of the perpendicular of the point px1 y1 on the line L is equal to ax plus by plus c is equal to 0 is 0. If h comma k, q h comma k is the foot of the perpendicular of the point px 1 comma y1 on the line ax plus by plus c, then the relation exists. What is that? H minus x1 by a, or I will write h minus x1 by a is equal to k minus y1 by b is equal to minus of ax1 plus by1 plus c by a square plus b square. This is the relation. If h comma k is the foot of the perpendicular of the point A, px1 y1 on the line ax plus by plus c is equal to 0. Then h minus x1 by a is equal to k minus y1 by b is equal to minus of ax1 plus by1 plus c by a square plus b square is true. I will draw a diagram with given data. Proof, very simple proof. If a straight line is this is the given straight line, ax plus by plus c is equal to 0, and there is a point px1 y1 on the plane. If we draw a perpendicular to the straight line ax plus by plus c is equal to 0 from px1 y1, then this is we call foot of the perpendicular. This is given as qh comma k. This is given as h comma k. Then the relation exists. How do you prove? It's very simple. First we have to draw. First we have to write the statement. Then we have to draw diagram. Then we will go to proof. Here PQ is a straight line and L is a straight line. L ax plus by plus c is also a straight line. given that these two straight lines are perpendicular. If the slope of these lines are m1 and m2, then by the condition the product of m1 and m2 is equal to minus 1. That means m1, m2 is equal to minus 1. Now we have to utilize that concept. The slope of given px1 y1, px1 comma y1 q h comma k and line ax plus by plus c is equal to 0. Therefore, slope of pq is equal to m1, put this is m1, that means k minus y1 by h minus x1. Okay. The difference of y coordinates by difference of x coordinates, that is w. Therefore, slope of ax plus by plus c is equal to 0 is m2 is equal to minus x coefficient by y coefficient, that is minus a by b. Since PQ perpendicular L is equal to 0, that implies M1, M2 is equal to minus 1. By substituting the values of M1 and M2, it implies K minus Y1 by H minus X1 is equal to, into minus M2 is minus A by B is equal to minus 1, minus minus get cancelled. The remaining k minus y1 into a is by h minus x1 by b is equal to 1. By rearranging these terms as h minus, if you bring this to right side, h minus x1 by, or we will write like this, another step, k minus y1 by b is equal to, if we bring this right side, h minus x1 by is will become as denominator. K minus y1 by b is equal to h minus x1 by a. Let h minus x1 by a is equal to k minus y1 by b is equal to some constant lambda, constant. Now substituting by taking the values of h and k from this relation, that implies h minus x1 by a is equal to lambda and k minus y1 by b is equal to lambda. That implies, if you taking h as subject, h is equal to a lambda plus x1 and k is equal to b lambda plus y. Since q h comma k belongs to ax plus by plus c is equal to 0, then this point should satisfy the equation. Instead of a, that implies ah plus bk plus c should be equal to 0. Since h comma k belongs to the point in that line, on the line, what is the value of h? A into a lambda plus x1 plus b into value of k is b lambda plus y1 plus c is equal to 0. By rearranging these terms, a square lambda plus ax1 plus b square lambda plus by1 plus c is equal to 0. That implies lambda, taking as common, lambda into a square plus b square is equal to, if we bring this remaining terms to right side, minus of ax1 plus by1 plus c. That implies lambda is equal to, if you bring a square plus b square to the right side, it will divide minus of ax1 plus by1 plus c by root of, a square plus b square. That is the value of lambda. If we put this lambda in this equation, put this is equation 1. Therefore, from 1 we have h minus x1 by a is equal to k minus y1 by b is equal to lambda. What is the value of lambda here? Minus of ax1 plus by1 plus c by a square plus b square, which we have to. This is the proof of the theorem. Hence proof.